Alright, so in this problem we are talking about this problem of Champernowne's constant for problem 40. So let's read out the problem. The problem is talking about the irrational decimal fraction created by concatenating for all the positive integers. So this fraction is created by concatenating all the positive integers. Let's say it started with 0.1, then 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14. So it means that if you remove 0 point something, this fraction part, it is just concatenation of all the positive integers from 1 to n number, 1 to a million number. Okay, so now if you look at, it says that 12th digit of the fraction part is 1. How 1 become 12 digit is because you see, before 12 digit we have 1 to 10. Okay, so 1 to 9, there is 9 number, then 10 has 2 digits, so 9 plus 2, 11, and then the 10th digit is from the first number of 11. Okay, that's how these numbers are calculated. So here we have to find out if dn represents the nth digit of the fractional part, find the value of this following expression. So we have to find out the value of this expression, which means ultimately we need to create a function. That function will take the number of n as input, and that will give the value of the digit from this fraction. Once we get this, then all we have to do, we have to multiply this. Okay, so that's our problem here, and let's see how we can solve it. Okay, first of all, what we'll do is we need to think about it. If we just, instead of fraction, if we imagine this as a list, okay, a list of digits, and if we consider that in our list there will be only one digit in our list, then once we figure out that list, right, then all we have to do, like, the digit of position of 1 for the list, position of 10 from the list. If we extract all this value, then our job is done, right? So let's see how we can solve this problem. So first of all, I'll create a function. That function will take the numbers, let's say number 3, 4, 5, and it should give us the digits of it. Okay, which we have done in previous example, but I'll just go and do it again here. So let me create this function, get digit from number. Okay, I'll take number as a parameter. Then let's say this is our list, which will be our output. Then I'm just going to do this while number greater than equal to 10, digit is equal to number modular division 10. So every time you modular division by 10, then you get the last digit from your the number. Okay, then I'm just going to append this, append digit, and then I'm going to divide the number, because I'm going to remove that digit, last digit. And finally the number, whatever remains, I need to append it, the last number, and the number will come in a reversed order. Okay, let's look at how is it working now. Okay, so if I try this function now, get digit from number, if I try 3, 4, 5, let's say, you see I got 5, 4, 3, I got in the reverse order. So therefore I'm just going to return the reverse of this list, 3, 4, 5. Okay, we got it. Now you can give any number, that will still work. Okay, now we need to find out one more thing. Basically we have to find out here, think about it. Here first we have a single digit number up to 9, 1 to 9. Okay, then we have all 2 digit number. Okay, that's 10, 11, 12, 13, etc. So after this will go until 99, and then we are going to have what 3-digit number starting from 100. Okay, and that 3-digit number continues. That means we need to keep a count of, let's say, 3-digit. If number of total 3-digit number, then how many numbers of 3-digit number exist? That's what we have to count. So yeah, so for example, if you want to find how many 1-digit numbers are there, that's, we know there will be 9 or 10 actually, but here because we're not considering 0, there will be 9. Now if you count 2-digit number, we know it is starting from 10 and ending at 99. That means there will be 90 such numbers. Okay, so let's just find out how do we calculate it. Okay, let's try to create a function that will give us this count. Okay, I'll just say I'll create another function, get len to number. So this length is the number of digit. Okay, the argument that we are taking is the number of digits. Then this will be kind of, 10, first of all 10 to the power the length. For example, 90 is coming as 10 to the power 10, that is 100, minus 10 to the power 1, 10. Okay, that is the case here. So 10 to the power length minus 10 to the power length minus 1. Okay, now because let's say we'll get 90 such numbers, but we have to count that every number size is 2, so we have to multiply that. Okay, then only we'll be able to figure out all the number of digits. Okay, so we need to multiply length here. Okay, now let's return this. So if I just try get length to number, if I give 1, let's say, I get 1. If I get 2, okay, there is something wrong. 10 to the power length minus 10 to the power length minus 1. Okay, let's try that first. We are taking length as an argument. I'm using wrong function. I'm calling wrong function here. Okay, that's why there is problem. Okay, so that function was good. Minus 10 to the power length minus 1, and then multiply it by length. So length multiplied by this, one more bracket. Yeah, so size of 2 is giving me 180 because this is 2 multiplied by 90. 90 such numbers, and each length of this number is 2. Now if I give 3, this will be, this will be again 2700. If you give it 1, then it gives 9. Okay, so you got the point. Now what we have to do, we have to finally create our function which we have been looking for. So we'll create the function called def get digit from position. Okay, so I'll pass the position as pos, and this function should give me the value in that position. Okay, so I'll just create a variable like size, start with 1, then I'll say current position is equal to 0. Let me give it a space here. Then so we are starting with size 1, and then current position is 0. Now I need to increment the position until I get my current position. Okay, so while current position less than position, it means that, okay, I can pass a position of 1 million. I'm starting with position 0 and then I'm just moving forward. Okay, and this size is the number of digits, and you know this digit will continue. So what I'm going to do is I'll increment the current position. Current position is equal to get length to number, like this function. I'll use this function and I'll pass the size. That means from size 1 till size as much as possible until I have reached my position. I need to increment the size. Okay, I'm just incrementing the size unless I have reached my current position. Okay, and now when we do this, actually we'll cross the size. Let's say if I'm at size 3, it's a 3-digit number. With this loop I'll cross 3 and I'll have size is equal to 4. That's why I have to reduce the size. Now I'm just trying to find out what is the number of digits. Let's say I pass position as 1 million. I need to find out whether it's a 7-digit number, 3-digit number, 4-digit number, and that's what this size will give us. Size minus 1. Okay, I have to decrease the size by 1. Now I have to give the current position is equal to, that means if my number is a 4-digit number, let's say, I'm just reducing it. I'll stop at 3-digit number and then increment from the 4-digit. Okay, count from the 4-digit. So now current position is equal to, I'll say current position minus, just decrement the last one. Okay, get length to number, size. Then let's find out the target number. Target number is equal to 10 to the power size minus 1. Then target number will be maximum of target number plus position minus current position, integer division of size minus 1. Okay, then we have to find out the offset. So this target number is basically, let's say the 11th position, the target number is 11. So that's the target number we are finding, and then we have to find out the offset. Okay, so 11, for example, 11th position offset is 0, whereas I could have a 7-digit number. I have to find out the target number. Let's say target number is 3, 4, 5, 6, 7, and then we have to find out the offset. If offset is 2, that means the 2nd digit from this target number will be our ultimate output. Okay, or the target digit. So target digit is going to be, now get digit from number, target number. Okay, and then so get digit from number, this will give us the, I got the target number. Now I am finding all the digits from this target number. Then I have calculated the offset. I have the offset. Okay, I haven't defined the offset here. Offset will be the position minus current position modular division of size. Okay, you got it. So if it is 7-digit number, we're just trying the current position. Current position is the beginning of that number, and then the target position, and modular division by size. That will give us the offset. Okay. Now here we take this offset and offset -1. So that's going to be our target digit. Now if we return that target digit, that should do our job. Okay, let's test this out. Okay, get digit from position. So we want to try this position number 11. Okay, there is some mistake here. Maximum of target number, then target number plus saying divide by 0. Okay, I think this is causing problem. Okay, yeah, here is a mistake. So we have to increment the size plus equal to 1. We have to increment the size here. Yeah, now this looks to be working because you see the 12 digit fractional part. Okay, if I just try the 12 digit is 0. Here 12 digits. Okay, 12 digit is 1. I think I'm getting 12 digit as this one. Okay, so let's try the 10 digit. 10 digit is 0. Okay, size is equal to this. Target number minus current position divided by size -1. Offset is equal to, that looks correct. Size starting with 1, current position is equal to this. Yeah, all looks correct. Okay, there is another mistake. This should be minus. Yeah, that looks correct. 12th position should be 1. Yeah, now it looks correct. So all we have to do is, now we have to multiply the first position, then multiplied by 10th position, multiplied by 10th position, then multiplied by 100th position. Okay, and just keep in another line here, 10th, 100. Okay, I'm just going to copy this. Then I know 1000 positions, 10,000 position, 1000, 10,000, 100,000 and 1 million. 100,000, we can do it like this, and 1 million. It's like that. Okay, let's multiply it. Okay, I missed the star here. 1. Did he make some mistakes? Let me do it like this. 10 to the power 3, 10 to the power 4, 10 to the power 5, and then 10 to the power 6. Yeah, I think I made some mistakes here. So this one looks correct. Let's try this answer 210. Okay. Yeah, that looks correct. Thanks for watching. Coming up next is problem number 41. Thanks.